Be ready! This video is not only to learn how to build a CRUD application with Spring Boot and React, but I also explain the best practices, some design patterns, and how to name RESTful endpoints. I'm going to build this CRUD application to create, read, update, and delete my gyms records. It's a video for beginners to build a full-stack CRUD application with Spring Boot and React. You only need some knowledge about Java and JavaScript or TypeScript. I won't go deep into those languages, so it doesn't require a strong knowledge. So let's see the agenda of today. I will start by creating a new Spring Boot project with all the necessary dependencies. Then create my first endpoint, a simple endpoint, to have the read operation. Then create a new React project with all the necessary components and request the backend. To allow an external frontend as React or Angular to communicate with my Spring Boot application, I need to configure the calls. Then in my backend I will connect a Postgres database to store all the information, create the entities and the tables. Let's continue with the CRUD operations, adding the create endpoint in my backend and create the form in the frontend to send the information to my backend. Then the delete endpoint to remove existing items in the backend. And finally the update endpoint to update some fields of an existing item in the database. By the end of the video you will be able to build a full stack CRUD application with Spring Boot and React, applying the best practices of a RESTful application. I won't cover the authentication. I've already made some other videos about that, where I authenticate an application using the JWT. And what about the unit tests? I won't write them. What? Okay, leave a comment if you want them. I will make a video later. So let's start, but please first subscribe to my channel and share this video to your friends who want to know how to build a full stack CRUD application with Spring Boot and React. To create a new Spring Boot project, I go to Spring Initializer. This page creates me a new project with the Maven configuration file, the folders structure, and the main class. I start by editing the group. Serger CRUD. The artifact. Let's name it Backend and use the name but with an uppercase. I leave the description, a jar packaging, I choose Java 21, the project dependency I will choose Maven, Java language, and leave the Spring Boot version, and let's now add some dependencies. I add web for the endpoints, JPA for the database connection, Postgres because I will use a Postgres database, and Lombok for the code generation. Here it is. Now I click on generate and it will generate me a zip file. I can unzip it and open it in IntelliJ. Here is my backend with the POM.xml for the Maven dependencies and the source folder. Inside I can see the main class. Let's now add another dependency, mapstruct, which is not available in Spring Initializer. Dependency mapstruct. From the group ID org mapstruct. I choose the latest version and I add another one, mapstruct processor. Both are necessary to build the mapstruct classes. Lombok generates me the getters, setters, and constructors, and mapstruct generates me mapping classes. I will need it when separating the objects from the database from the web object, the entity objects from the DTO objects. I will explain it later. As I don't have the database configured yet, I need to comment my JPA dependency. Otherwise, it will try to connect to a non-existing database. Let's now reload the Maven dependencies. Okay, now I can start my project to make sure everything works fine. I have two options, right-click on the main class and run, or from a terminal. Maven, Spring Boot, run. That's it, everything is running correctly. Let's now create my first endpoint, the endpoint to read data. I've created the backend. Later, I will connect the backend to a database, and I will create a front-end application to talk with the backend. But now I only have the backend. Let's focus on this communication. An endpoint is one public entrance to my application, an HTTP request. It consists in an HTTP verb, a URL, a body, and a response. Each of those parts has its meaning in the CRUD operations. But the main point is the format. In the old MVC applications, the format was HTML. In the streaming applications, the format is binary, but in a RESTful application, the format is JSON. For the read operation, the HTTP verb must be get. The URL must say which resource I want to read. The body will be empty, and the response will be the returned resource. Let's see a quick example. I want to read all the gym records. As said, the HTTP verb is get. The URL can be gym records, in plural, as I want them all. The body empty, and the response can have the following format. A list with many documents, each document describing a single gym record. Another example, I want to read a single gym record. As before, the verb is get. The URL is similar, gym, record and ID, the same base as I want the same gym record, but indicating the ID of the one I want. The body empty and the response as follows. This time it's not a list, but a single item. The thing is that the URL is built hierarchically, the more generic at the left and the more specific on the right. I want something about the gym. I want the gym records, but I only want the one with the ID 1. Okay, stop talking and let's implement that. I start by creating another package. And inside, my new controller. Records controller. I add the annotation, REST controller. This makes the difference between the JSON format and the HTML format I've said before. A lombok annotation. This is a lombok annotation to skip writing all the constructors. Private final records service. I create a service where I read all the gym records. The controller must have no logic. All the logic must be placed on the services. Get mapping and gym records. This is the URL of my endpoint, and the notation already says I use a get HTTP method. Public response entity of a list of gym records detail. The response entity is an object to prepare the JSON format of my response. On records, and I return the response entity, OK, and the result of the service. I name the same method. Let's now create the DTO. DTO means Data Transfer Object. Those are the objects I use to send and receive information from the frontend. I will explain the meaning when configuring the database. I will create another package, DTOs. I add some lombok annotations again. All args constructor, no args constructor, getter, and setter. And now the fields. Private long ID, private string exercise, and private integer weight. And finally, I create the service. Let's import the list into another package, services. I pick the same method name, public list, gym records DTO, and the method name. Import the list and add the service annotation. This injects the service into the Spring context. Having the service into the Spring context allows me to inject it anywhere. And now I return an array of gym records. New gym record, 1 bench press, 130 kilos. And the squat, 140 kilos. You don't bench press 130 kilos? Shut up! That's it. Let's run and test my first endpoint. I can test it from the terminal with curl or from Postman. I prefer curl. I'm a terminal guy. I run the application. Terminal. Curl. Localhost. 8080 gym records. Here is my gym records. If I add -vvv for a verbose output, I can see the headers. The incoming headers, where I see the get method and the URL, and the response headers with the 200 HTTP code. Let's continue with the next chapter, creating the frontend project. Now that I have an endpoint in my backend, I can create the frontend and displays what the backend returns me. To create the frontend, I have a simple command to run. npx create nx workspace at the latest and the name of my application, frontend. Yes, proceed. I choose React. No framework. A standalone application. I choose Webpack as a bundle. No end-to-end tests. CSS. Skip the CI compilation. And wait for the dependencies to be installed. I will write the frontend using TypeScript. If you know JavaScript, it's very similar. Let's now see the web page I want to create. To build this website, I won't add any library. I will just create some React component and add some CSS. The first thing to do is to split this view into manageable components. I have this vertical container, repeated 4 times, with a title. And inside the vertical container, I have some content boxes. The boxes are similar but not the same, with input fields, buttons, and displaying text. Let's start by creating a vertical container and placing it 4 times. Let's create a folder, vertical container, and a file, vertical container tsx. I will also create the CSS file. I start importing React. And declare the component, vertical container. Children. What is the React FC? This means that the vertical container can accept another React component as a children, as a property. What's the structure of the component? It's this one. It's an interface. Vertical container properties, which contains children, and is a React node. And inside I return the HTML, a div element with the children inside. I will add a class name, vertical container, and export the component at the end. I will add the CSS later. Let's start by adding it in the main component. Import vertical container from vertical container / vertical container. And now I add a class to this one, class name, main component, and inside I add my vertical container. As said 4 times. And now let's add the children. For the moment I only add the title. In h2 title, create h2, and I add it to the 4 vertical containers. Each one will represent a CRUD operation. Create, read, update, and delete. I will now start the front end to edit the CSS easily. I will start by creating another CSS file for my main component. I will name it app.css. I import it in the tsx file, import app.css, and now I add the CSS here. I want my titles to be in columns instead of rows, so I add the main component definition and display as a table with the width at 25%. Okay, but each element is inside a div tag, so the div will be a display table cell with the width at 25%. Sorry, here it is 100%. So each column, each vertical container has a 25% of the page. Let's now go to the vertical container to add some other style. I have the CSS file here, but I need to import it in my vertical container TypeScript. Import vertical container CSS. And now in the vertical container, I start by declaring the class vertical container. I will add some shadow to distinguish each box. Shadow GBA 0.24 and the direction. Let's see the result. Let's add some margin between boxes. I will add a min height of 400 pixels. Okay, even if I have no content box, this will be the minimum height. I will add a padding at the bottom to avoid having the boxes on the bottom. And now for the title, I add a padding at the top to avoid having the title on the top of the box. I align it to the center and increase the size. I have my vertical container ready, the vertical container that will contain each CRUD operation. So now I will fetch the backend endpoint. I will request the read operation I've created before. Let's start by creating an entity where to store the results of the backend. Because with TypeScript all the variables must be typed. I can't work with unknown objects. All the variables must have a type. That's why it's called TypeScript. That's the difference with JavaScript. I create a new directory, entities, and inside record.tsx. I export the interface, gem record, with the fields ID as a number, exercise as a string, and weight as a number. And now, in the app component, in the main component, I use the use effect to request my backend when loading the component. Why requesting backend in the main component? Why don't I do it in the vertical container or in the content boxes? Because I need the list of the gem records to be stored in the main component, accessible for everyone. And the parent component will iterate over each item, displaying as many content boxes as gem records. When creating a gem record, I must do it in the parent component, because after creating the gem record, I must append it in the existing list. And where is the existing list? In the main component. Same for the delete and the update operations. Go to the app component, import React. To use the use effect and use state, I start to declare the list where to store the records and the setter, set records. Use state, it will be gem records, an array, and I initialize it as empty. Let's import this, import gem record from entities, gem record, and now the use effect. React use effect. It's the global setup, so I bind it to no variable. And inside I fetch my backend HTTP localhost 8080 at gem records with the following options. Method get, nothing more. And the response, then if the response status is 200, I return the response as a JSON. Otherwise, I return 0. And the response of the JSON method is the data. If the data is not null, I set the records. So I fetch my backend. The response of the backend will be a response entity. This one I transform it in JSON, and the JSON will be the list of the gem records. Let's see in the browser. Here is the frontend. If I reload, I see that the request was not sent successfully. I have a course error. This is known as the course error, cross-origin resource sharing. It's the default behavior of the browsers to forbid access to the backend from different frontends. My backend has a URL of localhost 8080 and the frontend has a URL of localhost 3200. And the browser asks to the backend, hey, do you know this frontend? By default, a Spring Boot application only trusts itself. So let's solve this. Let's create another package in my application where will be located all the configuration stuff. I will name it configs. And inside, web config. I add the configuration annotation to allow Spring read this class at loading time. Declare the bin, and now the web MVC configurer, course config. I return a new instance of web MVC configurer and implement only the method to overwrite the course. Registry, add mapping to all routes, allow the methods get, post, put, patch, and delete. And I allow the origins, which is the frontend URL, http localhost 3200. That's it. Let's test again the frontend. Now in the network I see two records requests, both OK with the 200 code. One is the options and the other returns me the records. I can see in the response tab the two records as set. So let's create a content box where to display the result of the backend. I'll start by creating another directory. Content box. And inside the read content box .tsx. Const read content box. Import React from React, and now React FC content box properties and the content. And now let's define the content box properties. Interface content box properties, and it's only one field content, which is a gem record. Let's add the import as before. Here it is. And now I will create a useState variable with the record, a single record, to be displayed in this content box. Record, set record, React useState, which is a gem record, and initialize with the content I've received as input, and return the rendering of the component. A div. Let's add a class name, content box, and inside I display a paragraph, exercise, record.exercise, and another one for the weight, record.weight in kilograms, and at the end export. Sorry, it's FC, not RC. Let's now use it in the app component. Import from content box, read content box, and in the read vertical container, I iterate over the records, the variable I've created before, and map each single record into the read content box with the single input variable, which I've named content, with the record. I will also add the key property. Record.it. What is the key element? With React, each item in a list must be differentiated by a key. This way, React only updates the view of the affected element I've modified in the list. Here it is, the two content boxes, but let's add some CSS to make this more pretty. I add a CSS file, content box.css. I import the CSS in the read content box component. Import content box.css. And now let's edit it. I've added a class, content box, and I will start adding some shadow. Box shadow, RGBA, 100, 100, 111, and dot 2. The direction 0, 7 pixels, 29, and 0 again. Okay, better. Let's add some margin, 5 pixels, margin at the bottom, 30 pixels, to leave the shadow under each box, some padding. Okay, better. This is fine, but what would be interesting is to read those items from the database. So let's create the database and connect my Spring Boot application. To create a database, I will use a single Docker command. Docker run -e to add an environment variable, Postgres, host, auth method, trust. This allows me to connect from everywhere. Postgres, user, backend. This is the name of the user. Postgres, password. Backend. This is the password of the user. Postgres DB, backend DB. This is the name of the database. And now the port 5434, mapped to 5432. The first one is the port on my machine, and the second one is the port of Postgres inside the Docker image. And now the image, Postgres and the version 14. Here it is, it's running. Now go back to the backend and uncomment the GPA dependency and configure the database access. On POM.xml, I remove these comments. Reload Maven, and now I go to the backend configuration file, main resources and application properties. I will rename it to the YAML file. I prefer YAML. It's less verbose. Okay, Spring, data source, driver, class, name, org, PostgreSQL, driver. This is the driver, the class of the Postgres driver. URL, JDBC, Postgres, localhost, 5434, and the name of the database. This is where to locate the database. Now the username, which is backend, and the password, which is also backend. And now the JPA configuration. The database platform, org.hibernate.dialect.postgres SQL dialect, and Hibernate, DDL auto, create and drop. This means that each time I run my Spring Boot application, it creates a new database with this configuration and all the entities configured in the Java classes into the database. And when I stop the application, it drops all. With this configuration, my backend is connected to a database, but I have no tables and no way to request the database. So first I will create the entities, which are the Java object which represents a table. Then I will create the repositories, which are the interfaces to communicate with the database. Let's now create a null package. Entities. And inside, Gym record. As usual, I add the Lombok annotations, all args, no args, getter, and setter. And now, the entity, to tell Spring that this class is an entity, is mapped to a table in the database, and the table annotation to indicate a different name in the database. Gym record. If I don't specify this, the table in the database will be named as Gym record, as the class name. And now the three columns I want. Private long ID, private string exercise, and private integer weight. The ID will be an ID, of course, and it will be a generated value. How? I will choose a strategy. Generation type, with a sequence. A sequence in the database. It's an incremented value. Each time I add a new exercise, a new gym record, this ID will auto-increment. The exercise, I add the column annotation. And the weight, I add the column annotation. This way JPA will link this field to a column in the database. And now the repository. Let's create another package. Repositories. Gym records. Repository. Extends JPA repository as a gym record from along. It's giving an error because it must not be a class but an interface. So, asking for an ID, I get a gym record. With the repository, I don't need the annotation of service, repository, component, or other, because extending JPA repository already loads this repository into the Spring context. By default, extending this repository creates me a lot of methods to request the database. And now let's update the service to use the repository instead of the hard-coded list. I add the repository, private final, gym record repository, but I need to inject it. Required args constructor. And now when asking all the records, I find all. But I can't directly return the output of the repository to my service because my repository returns gym records and my service returns gym records DTOs. Here comes the usage of mapstruct. With mapstruct, I map my entities to my DTOs. Why? This allows me to hide some fields from my entities, columns of my database to the frontend. My tables may have some columns like passwords, bank accounts, or secret data. And I don't want to expose all those columns, all those data to my frontend. So I hide them. I choose which field I want to expose to the frontend. Let's create another package, mappers. And inside, an interface, gym record mapper. First annotation is mapper. With component model as Spring. This allows me to inject the mapper with Spring and add some methods. Gym record to gym record DTO. This method maps a DTO into a gym record entity. Let's do the reverse from an entity to a DTO. And finally, I make the same but with a list. The methods will be automatically created by mapstruct, mapping each fields which are named equally in the gym record and in the gym record DTO. And now let's use the mapper in the service. I add another one. Private final gym record mapper, and I will map the result of the repository to the result of the service. The mapper to gym records DTOs. So the mapper reads the list of gym records and maps it into the list of gym records DTO, which is the output of the service. Before I had my gym records hard-coded, but when I've added the database, it's an empty database. I need to add some data inside. I need the create operation. Let's start with the backend with the new endpoint, the create endpoint, to create a new gym record. And then in the frontend, I will create a new content box with an input form. Let's go to the controller and add a new endpoint. Post mapping this time. Gym records. Public response entity as before. I return only a gym record create gym record, but this time as input variable I have another gym record DTO. Sorry, it's a gym record DTO. But I have to add the notation request body, because the gym record DTO will come as a body, as a payload, a JSON document. Now I call the service, record service, create gym record with my DTO, and it will return a created gym record. And I return my response entity. Created URI create gym records plus the created gym record ID with the body of the created gym record. Sorry, I didn't explain the URL structure of the create operation. This was the structure of an HTTP request for a read operation. The get verb, the URL describing which resource I want to read, no body, and it returns a list of the resources I asked for. For the create operation, I use the post verb, the URL indicating which resource I want to create, I send the body of the content I want to create, and in the response I receive the content of the created resource. Using the same URL for the create and the read operations won't cause any problem? No, because the verb is different. Spring Boot differentiates both requests and map them to different endpoints. With the read operation, I use the get verb because I want to get many gym records. Now with the create operation, I will use post because I post a new gym record to the existing list. But let's see in details the response. With the read operation, I receive the list of the gym records with the HTTP response code 200, which means OK. With the create operation, I receive the created entity with the HTTP response code 201, which means created. But the 201 HTTP code is never alone. It goes together with the URL where to find the created resource. This URL can be found in the HTTP headers of the response. In Spring Boot, I can do all this with the response entity object. Let's continue now with the service. I copy the service name, public gym record DTO, and as input another gym record DTO. First I map the DTO into an entity with my mapper to gym record DTO. Now, with my repository, I save the gym record. The repository will return me the created gym record. I need this new object because inside I will have the ID, the created ID. And finally, I return the gym record DTO after mapping it into a DTO again. Let's continue with the frontend, creating the content box to upload a new gym record. Let's go to the content box folder. I will copy the read content box and modify it. I rename it into create content box. Create and create. I won't have any input in the content box properties. Instead, I have an onSubmit method with the exercise as a string and the weight as a number. And it returns a void. The onSubmit is when I create the gym record, it will be submitted to the backend. Is the only input parameter, which is a method. As variables, I have the exercise and set exercise. Using useState, I initialize it to empty, and the weight, and set weight. useState. Now my content box has input fields instead of paragraphs. The first one is type text. The value will be exercise, and on change I take the event and set the exercise. Event target value. And as the placeholder, exercise name. Let's do the same for the weight. This time is a number. The value is weight. I have to parse to an integer. And the placeholder, weight in kilograms. And at the end, I add a button. On click, create. What to do in the onClick? I call the method handle submit. Let's create this method, const the method with no input variables. It calls onSubmit. The input variable I've received with the create content box with the values exercise and weight. Or if I don't have a weight, I set to 0 and I reset the exercise to empty and the weight to 0. Let's add the content box in the main app component. Create content box, on submit, and the create submit. Let's create this method. As input I have exercise as a string and weight as a number. What to do inside? I fetch the backend, HTTP, localhost, 8080, Gym records with some options. Method as post, headers is the content type, application JSON. This allows me to indicate that the body sent to the backend will be in JSON format. And finally, the body. JSON stringify, exercise, weight. This method will convert this object into JSON. Those are the keys and those are the values, the input values received in the handle create submit method. Once the request is done, I take the response. If the response status is 201, I return the response JSON data. Otherwise, return no. Finally, with the data, if the data is not null, I set the records list of the main component. I add the already existing records plus the new data. Let's now add some style to this create content box. I first select the input, content box, and then the inputs. I set a maximum width padding to be bigger, some margin at the bottom, margin to separate with the buttons, and between them a border, more gray, and rounded corners. Let's go now with the button, content box, and the button. Also some padding. Another background color. Blue. The color of the text, white now. To be readable. No border. A rounded button. The cursor as a pointer when I pass over the button. And finally, limit the width. And when I am over the button, I change the background color. Yes, that's it. Let's now create a new gym record. Bench press 130 kilos. When I hit in the create, a request is sent to the backend. But at the same time, the document is stored in the records list of the app component. I have the create and the read operations. Let's go with the delete operation. I leave the update operation to the end, because it has some complexity. For the delete operation, I have another verb, delete. The URL now describes not only the resources to delete, but must contain the ID of the record I want to delete. There is no body, because I am able to identify the resource to delete only by its ID. And the response contains the deleted entity with a 200 HTTP code. Let's start by creating the new endpoint in my backend. I go to the controller and add a new one. This time is delete. Gym records, and now I add the ID. Public response entity as always. It returns a gym record DTO. Delete gym record with the ID. To read the ID from the URL, I have to add the annotation path variable. And now call the service records service delete gym record with the ID. And this will return a gym record detail that I wrap into the response entity. OK. I copied the service method name and let's go to the service. Public gym record DTO with the long ID. First of all, I will search for the gym record. So I call the gym record repository, find by ID, ID. If it doesn't find this gym record, it will throw an exception. And leave it empty for now. And if it finds it, it will return a gym record. Gym record repository, delete by ID. But before deleting it, I call the mapper to obtain the DTO. Because the DTO is the one I return at the end of the method. But what happens if I don't find the record I want to delete? The best option is to throw an exception. Exceptions are here to tell that something went wrong. I want to delete a gym record, but I don't find it. That's not good. But which exception? I will create my own exception. As this is my code, I should use my own exception. Let's create a new package. Exceptions. A new class, app exception, which extends runtime exception. Private final, a single field, HTTP status, a constructor, public app exception with a message and the HTTP status. I set the status and call the super constructor with the method. And finally, the getter. Let's now return to the service and use this exception. New exception, gym, record not found, and throw an exception with the HTTP status not found. The exception should describe the error, but what is the HTTP status? In a REST application, I have the HTTP request and the HTTP response. We saw at the beginning that the request is composed by a URL, a verb, and a body. Each element tells about the action and the resource. And we also saw that the response has some useful information, as the body and the HTTP code. We saw that the HTTP code 200 means OK, everything was fine. The code 201 means created. I've created the resource you asked me. But there is some codes about errors, like 404, which means not found. I didn't find the resource you asked me. There are a lot more codes, divided into 5 categories: information, success, redirection, client error, and server error. But I won't explain all them. I will just use the 404. But how do I convert my own exception into an HTTP response with an HTTP status? I need to configure the advice. It's a piece of code that will always be executed when Spring Boot catches an exception. It's called aspect-oriented programming. In the config, I add another class, REST exception handler. It's a controller advice. This means that it will wrap all the controllers, and inside I add an exception handler, which catches only the exceptions app exception, the one I've created. It has a response body, which means that it returns a JSON document, and now let's implement it. Response entity error DTO. I will create another DTO to return the exceptions. Handle app exception X. And I return directly a response entity body with the status X. I read the status from the exception and the body, new error DTO with the message. Let's now create this DTO in my DTOs package as a record with only one field, message. I add the import, and that's it. Let's go to the front end to create another content box. It will list the details of the gym record as the read content box, but I will also add a button to delete a gym record. Let's create another content box component. I copy the create one and rename it into delete. Delete and export at the end. This time the onSubmit method has not exercise and wait, but only the ID. But it receives the gym record to display. Content as gym record. So the input variables will be onSubmit and content. I save the content as a record. React user state gym record. Initialize the content into the record variable. In the handle submit, I call onSubmit, but only with the record ID. I remove those fields, and I have again the paragraph. Let's copy it from the read content box. This time it's delete. Let's copy it and add it to the main component. As with the read component, I have to iterate over the list of the records. Record, map each record into delete component box with a key. As for the read component, with the onSubmit method, handle delete, submit, and the content, which is a record. Let's create this method. It reads the ID as a number, and the content is fetch the backend URL, localhost 8080 gym records plus the ID. Let's change it double quotes into the back quotes. Add some options, as the method is now delete, and that's it. The response as before. I copy it. If the status is 200 this time, I return the JSON content. And finally, with the data, what I will do now is filter the received record into the records list. Records. I take all the records and filter the record which has record ID different from data ID. This way I delete the received record from the records list. Let's create again a new gym record. Squat 140 kilowatts. This time, when I create, I have the records list, which is read in the read column and in the delete column. The delete column now has a delete button, which is mapped with the ID of the record. If I click on it, I remove the gym record from the records list. This makes the record disappear from the delete column and from the read column. Finally, the last operation, the update. I leave it to the end because now the question is, when updating a gym record, do I update only the weight, the exercise, or both? Or do I update the complete gym record? I have both options. Updating the fields individually must be done with the patch verb, and updating the complete gym record must be done with the put verb. What about the post? I can't use the post because it's not idempotent. You don't know what idempotent means? They didn't teach you what idempotent means at school. What color is the sky?
Blue.
What color is the sun?
Yellow.
What does idempotent mean?
The same request must produce the same result, no matter how many times I execute it.
That's it, the same request must produce the same result, no matter how many times I execute it. If I update a gym record setting a new weight, the result in the database will be that the record will have the given weight. I can send the same request as many times as I want. Each time, the row in the database will have the same result. But what happens when I post a new gym record? A new row is created, and if I repeat the request, another row is appended. Okay, but let's go back with my update operation. I will implement the put operation to replace the entire gym record. Let's start again with the controller. Now I use the put mapping. Gym records with the ID again. Public response. Entity. It returns the updated gym record. Update gym record. And as before, I use the path variable with the ID. But I also need the request body with the gym record, with the updated gym record. Now I call the record service update gym record with the ID and the gym record detail. This returns me a gym record detail that I wrap directly into the response entity. Okay, that's it. Let's continue with the service. Public gym record detail update with the long ID and the gym record detail. As before, I first need to check if the gym record exists in the database. Otherwise, I throw an exception. Then I need to create a new method in my mapper to update the fields from the DTO to the entity. Let's call it update gym record with the gym record and the DTO. And finally, with the updated gym record, I save it with my repository. Save it, gym record, and return the DTO after mapping it from the saved gym record. Let's now create this new method in my mapper. Void gym record and gym record detail. But now I need to identify that this is the target field. Mapping target. And I want to ignore some fields. Target ID, ignore ID. Because I don't want to override the ID. And now let's go to the front end. The last part, and my CRUD application is ready. Let's create another content box. I will copy the delete one. Update. Update content box and update content box. The update content box will have two input parameters, the onSubmit, but with a gym record, and the content as the gym record to be displayed. So I leave the record variable, I leave the handle submit, but it will submit the record, the entire record. I leave the button, but instead of paragraphs, I will use input elements. I will pick them from the create content box. And now passed. But this time in the onChange, I can't set the exercise or the weight individually. I have to set the record. So I set all the fields of the existing record plus the exercise with e target value. Same for the weight. Weight and parse int. This will set all the previous fields of the record, which are the ID, the exercise, and the weight, and finally override the exercise or the weight field, and finally the name of the button, update. Let's add this new content box into the main component. I start with the import and go to the column update. Here it is. I will pick the delete one and copy. Update content box with the record, the handle. Update, but this time the key must be something different. Record exercise and record weight. In the key field, I must include the exercise and the weight values because they may change. This way, React notices that a change occurs in an item of the list and the component is updated. So let's create the handle update submit method. Const. The input is the record to update as a gem record, and the content as before, fetch http localhost 8080. I can pick this URL because it already has the ID and the options. The method is now put. I need the headers. I can pick them from the create method. I can also pick the body. As always, once I get the response from the backend, I check 200 code. And once I parse the response into JSON body, I update the record. How do I do that? I take the records list and map each element. I first check if the record equals to the input record, to the received record. If that's the case, I leave the rest of the record fields and update the exercise value and the weight value. If the ID doesn't correspond with the incoming ID, I return directly the record. And now, to be sure that the records are updated in both the create, delete and update columns, I need to use the same key. So I go to the update column, I copy the key and paste it in the delete column and in the read column. Let's now test all together. I start by creating a new exercise, biceps curl 20 calories. Create, and it appears in the three columns, the read, the update and the delete. If I update this record, let's say 22, click on update, and both the read and the delete columns are also updated. Let's make a quick recap. I've created the backend with Spring Initializer. I've added the web dependency for the endpoints, JPA and Postgres for the database connection, and Mapstruct and Lombok for the code generation. I've created the controller with all my REST endpoints. I've created the service and repository where I read and update the gem records. I've created the entity, which is an object which reflects a table in the database. I've configured my backend to accept an external frontend with the course. And finally, I've added an advice to catch my exceptions and return the HTTP code I want. On the front-end side, I've created the project with NX. I've created a vertical container where to place all my content boxes. I've created one content box per CRUD operation. And I've created the actions of the content boxes in the app component, where I've stored the list with the gem records. That's all for this long format video. Now you have all the keys to build your own CRUD application. Check my other videos where I've added the authentication to a React application. It may be interesting to combine both. Now it's time to make me a favor. Like the video, add thank you in the comments and share the video. Don't forget to subscribe to my channel and see you soon. Bye!